Hello guys, my name is Nandavardhan Reddy from third year ITA section, Informational Technology, bearing roll number of 20951A1248. Today we are going to learn about knapsack algorithm. Knapsack algorithms. Okay, let's go to the introduction. Knapsack problem. You are given the following: a knapsack, a kind of shoulder bag with limited weight capacity. A few items each have some weight and value. This is the bag you can see here. This is the few items that have some weight and values, and a knapsack means is kind of shoulder bag. Okay. The problem states which item should be placed into the knapsack such that the value or profit obtained by putting the items into the knapsack is maximum. We should keep items into the bag such that we should get maximum profit. Okay, maximum profit. And the weight limit of the knapsack does not exceed. The weight also limit maximum bag weight should be we should keep the items. Next, knapsack problem variants. In knapsack problem has the following two variants. One is fractional knapsack, 0 or 1 knapsack problem. First, we will discuss about 0 1 knapsack problem. In 0 1 knapsack problem, as the name suggests, items are indivisible here. It cannot take the fraction of any item. We have to either take an item completely or leave it completely. It is solved using dynamic programming approach. In zero knapsack problem using dynamic programming. Consider consider a knapsack weight W, number of each item should be weight and value equal 10, and zero knapsack problem is solved using dynamic program in the following steps. First step, draw the table say T. This is the table T with n minus 1 number of rows, n plus 1 number of rows, and w plus 1 number of columns. Fill the all columns, all the boxes of 0th row and 0th column with zeros as shown here. As shown, we should be filled first column and first row with zeros. Step 2. Start filling the table row wise, top to bottom from left to right. Use the formula T of I comma j equal to max of T of I minus 1 comma j comma value of I plus T of I minus 1 comma j minus weight of I. Here I are j are row and column numbers. 0 row, 0 column, 0 first row, first column, second row, second column, or first row, second column. In this way, we should calculate the T of I comma j values, where T of I comma j equal to maximum value of the selected items. If we can take item 1 to y and have weight restrictions of j, this step leads to completely filling the table. Then the value of the last box represents the maximum possible value that can be put into the knapsack. Here, which value comes here means here we see the here which value comes here that's is the maximum value that can be put in the bag. Okay, then next to step 3, to identify the items that must be put in the knapsack to obtain the maximum profit, consider the last column of the table. Start scanning the entries from bottom to top and encountering an entry whose value is not same as the value stored in entry immediately above it. Mark the row label of the entry. After all the entries scanned, the mark label represent the items that must be put in the knapsack. Under the time complexity here, we see each entry of the table requires constant item, big O of 1, theta for its computation. It takes theta of nw times to fill n minus 1 into n plus 1 into w plus 1 table entries. It takes 0 of 1 n theta of n time for tracing the solution since tracing process traces the nth rows. Thus, Overall theta of NW is time is taken to solve 01 knapsack problem using dynamic problem programming. Here the problem given. For the given set of items and knapsack capacity equal to 5 kg, find the optimal solution for 01 knapsack problem. Make using of dynamic programming approach. Here are item and weight and value given for this problem. Solution is given knapsack capacity 5 kg and the total number of items is 4. Step 1. Draw a table T with n plus 1 rows and a W plus 1 columns. Here see n plus 1 means 5 plus 4 plus 1 rows means 5. 5 rows should be 5 rows. 1 0 to 0 to 4 rows are drawn. And W plus 1 columns means 5 plus 1 6. 6 columns are drawn from 0 to 5. Fill the all the boxes of 0, throw on 0 column with 0. See here we filled zeros and zeros across first column, first row. Then we should find the solution. Step 2. Start filling the table row-wise, top to bottom, from left to right using the formula. See, by using this formula, we should fill the table by T of 1. We should take I equal 1, J equal 1, value of I equal to L of 1 equal 3, 2. Substituting the values, we get T of 1, 1, comma equal 0. Again, for finding T of 1, 1, comma 2. We will get T of 1 comma 2 equal 3. For 1 comma 3, we'll get 3. And for 1 comma 4, we get 3 again. For T of 1 comma 5, we'll get again 3. For 2 comma 2, we'll get 3. For 2 comma 2, we'll get 3. 2 comma 3. 2 comma 4, we'll get 4. For 2 comma 5, we will get 7. Similarly, compute all the entries. Similarly, like this, we'll get after all the entries are computed and fill in table, we get the following table. This table we will get at last. The last entry represents maximum possible value that can be put into the stack knapsack. So maximum possible value that can be put into the knapsack equal to 7. This is the maximum value put in the bag. Identifying items to be put into the knapsack. Following step 4, we mark the rows labeled 1 and 2. Thus, items that must be put into the knapsack to obtain the maximum value 7 are to obtain maximum value 7, we should keep item 1 and item 2 in the bag. Fractional knapsack. In fractional knapsack problem, as the name suggests, items are divisible here. You can even put the fraction of any item into the knapsack if taking the complete item is not possible. This solved using greedy method. Here these items can be put into the bag by fraction. Means 2 kg of rice. If we have 5 kg of rice, can put 2 kg of rice. Like 5 kg of sugar, we can take 1 kg of sugar. Like that. Okay. By seeing profit, we should take the fractional of the items, fractional part of the items. Fractional knapsack problem uses greedy method. Is solved using greedy method in the following steps. Step 1. For each item, compute its value by weight ratio. Step 2. Arrange all the items in decreasing order of their value by weight ratio. Start up putting the items into the stack beginning from item with the highest ratio. Put as many items as you can into the knapsack. Time complexity. The main time-taking step is the storing of all items in decreasing order of their value by weight ratio. If the items are already arranged in the required order, then while loop takes big O of n times. The average time complexity of case sort is n log n. Therefore, total time taken including the sorting is big O of n log n. Problem. For the given set of the items and knapsack, capacity equals 60 cases. Find the optimal solution for the fractional knapsack problem uses for greedy approach. Here are the items, 5 items given, and the weights of 5 items were given, and their values also given. For solution one, first step one, compute the weight by value ratio for the each item. Weight by ratio, five, value 30 by 5, 6, 40 by 10, 4, 45 by 15, 3, 77 by 22, 3.5, 90 by 25, 3.6. These are the weight by value ratio. Then sort all the items in decreasing order of their value by weight. Okay. Here we, according to this, sorting order is 6, 4, 3.6, 3.5, 3. 6, 4, 3.6, 3.4, 3. Item 1, item 2, item 5, item 4, item 3 are decreasing order of their ratio by value by weight ratio. Start filling the knapsack by putting the items into one by one. See, knapsack 60 items that items in knapsack cost 0. This one item 1 inserted 30, item 2 inserted 70, item 3, item 5 inserted 160. This way, now knapsack weight left to fill is 20 kg, but its item 4 has weight of 22 kgs. Since in fractional knapsack problem, even the fraction of item can be taken. So the knapsack will contain the following items. Item 1, item 2, item 5, and 20 by 22 ratio of item 4. The total cost of the knapsack is 160 plus 20 by 27 into 76. 160 plus 70 total equal to 30. These are the zero knapsack and fractional knapsacks. Thank you.